In this position would be a 5. In this position would be a -8. The matrices have to have the same exact elements in both, in the same order. So this is saying that 5 is the same as 2x plus 7. So set it equal to 5 and figure out what x is. Your matrix, each element, each corresponding element has to be the same. Your 12 is equal to your 3y, and your 4 is equal to your 3z minus 14. Just a good exercise in when matrices are the same. And then the next part, did you have any questions on these? Adding them, can you get them in your calc? Did you add them? And all that other good stuff? Yeah, good. Okay, everybody okay with this? Subtracting them. I did the intermediate steps out in case you did. You wanted to see them. But absolutely, you could put this statement in your calculator. 3 matrix A minus 2 matrix B. The only thing you have to remember is you have to use the matrix, the symbol from the matrix section. You can't use the letter A. That's just a variable in your calculator. So you have to go to matrix, pull up A, pull up B, whatever, and just click on it. You need the matrix one. We look at it like this, like an A, B, C here, but when you do it with your matrix, it has to come off your matrix. So is everybody okay with this? Questions? No? Good. Not a bad one to do. Just to get used to doing some matrix work. Again, I just gave you a different one, 3 by 3. Your orders have to be the same for you to add and subtract. So the first one is a 3 by 2. The second one is a 3 by 2. You can add and subtract those. The orders have to be the same. Again, just put your AB into your matrix and then do one statement at a time into your calculator. And you didn't have to do the interim one. I just did in case you did. Remember, this is called scalar. When you multiply by a number, you multiply every entry by that number, a scalar. And your calculator will do all that for you. Kind of cool, right? Matrices are kind of fun. Just so that you have the, the groundwork for your matrix work. Chris? Actually, they don't really use a matrix in calculus. They really only use it in precalc, usually for systems of equations work or determinant. You may have to do a determinant in calc, but no, you would use a calculator. You'd absolutely use a calculator. In calculus here, most calculus courses, yeah, you would use your calculator. The only time you wouldn't is if you took like a college algebra class. Some people, like usually, I hate to say this, but it's usually the older ones that aren't comfortable with the calculator will make you do them by hand. And they also think that that is also more important to be able to understand how a matrix works. But usually you can use your calculator.
So how to take the last answer is 22, 8, maybe get that.
This, 3 times A, which is this guy, 2 times B, which is this, then subtract. So 24 minus 22. 24 minus 2, 22. 6 minus a -2, 8. -12 minus 2, -14. We're subtracting. Oh, all right. Yeah, 1 just throws everything out of kilter there. Okay? Again, you're in a 2 by 5 and a 2 by 5. Just another order for them so that you're still adding your corresponding entries or subtracting your corresponding entries. I did the interim ones out in case you did them yourselves out that way. You're going to do the 3A, so I threw the 2B in there in case you wanted to subtract them by hand. Sometimes it's easier to just add and subtract them by hand than it is to put them in your calculator. Go through all the steps of the setup. 19, you have to tell me if these were possible. You can't add or subtract them because their orders are different. The first order is 2 by 3, and this guy is a 2 by 2. The orders have to be the same to add and subtract. If you're going to add or subtract. Scalar, you can multiply any matrix by a number. That's fine. And again, we can't subtract because they have to be the same. Could we have multiplied these? If this is a 2 by 3 and this is a 2 by 2, could we have multiplied them? Nope, couldn't multiply them either. Good. Right, this is kind of like, can you do this or not? Yes.
To add them, you have to have like the same number of like columns.
Yes, because you have to add right on top of the other one.
Same thing for multiplying or
No, multiplying, we have a different rule for multiplying, which well, I'll talk about with the next one here. Okay, these guys, we solved for x. This one is in terms of x, the same thing you just basically did up on top, 3a minus 2b. This one you had to get x by itself. Remember yesterday we did one similar, we took and I just pulled the 1/2 out rather than left it as a divide by 2. I just pulled the 1/2 out. Sometimes it's just easier. And if you do this in your calculator, remember, you can go to math, fraction, enter. And this will let you return it to a fraction. This one wasn't too bad because it was just one decimal point. It's the yesterday's one when it was a repeating decimal that was bad.
yeah, I think I got like the different way of solving the thing, but I got the same answer.
You did? Okay. Did you do this first? You probably did b minus 3a and then you just divided everything by 2.
No, I did 3a equals negative 2x plus b, and then I subtracted b on both sides and got 3a minus b equals negative 2x, and then I divided both by negative 2.
Okay.
And I got x equals negative 3 over 2a plus 1/2 b.
That was fine. You just distributed that. And yours just went the opposite way. That was absolutely fine. Absolutely fine. As long as your math is sound in solving the equation, that's fine. Okay. And these were the multiplied. For anybody not here, I think it was just you, Alex. When you multiply, you write the order down. So this is a 3 by 2. This is a 3 by 3. These guys must be the same if you're going to multiply. If these are not the same, then you can't multiply them. If they are the same, then this 3 by 3 is the matrix you end up with. So this just said, is this possible? And no, this is not possible. So we stop.
You said undefined.
Undefined. Yep. Undefined. Absolutely. That's the better word to say. Undefined. Okay, number 35, you didn't have to do it by hand. You just had to say that was a 3 by 2, this is a 2 by 2, this right here is good, so we're going to result with a 3 by 3. With a 3 by 2. And that's our resulting matrix right here, a 3 by 2. Now you could put it in and just do the multiplication in your calculator. I did these out, but remember when I was telling you yesterday that this row has to do this column, then has to do this one, then this row has to do this column, then this one. That's all this work right here. So I'm not requiring you to do that. Just put it in your calc, and the chances are, if you did it by hand, you kind of have to look it up if you had to do it again. The multiply is a little bit different. I'll gladly go through it if you want to, but I didn't really think it was that necessary to get the same result a lot quicker in your calculator. It's good technology. Your calculator is very good technology. So there's a 3 by 3 and a 3 by 3, so the 3's were the same, and it results in a 3 by 3. A little bit different. It's like this is the whole thing out by hand. It's long. and you didn't have to go by hand. This next one, you're a 2 by 1 and a 1 by 4, so you'll result in a 2 by 4 when you multiply. Okay, and I think that was it, right? Okay, any questions? No? You guys that were in here, Rachel, Alex? Okay, your determinant, guys, is a real number. It comes out to be one single number, and it's associated with a square matrix. Aaron, what constitutes a square?
Constitutes square.
What does a square look like?
The number square, or we're talking about the shape.
Square.
Those like four sides.
Four sides that are the same length, right? So, to make it a square, in terms of a matrix, if it's a 2, it's a 2 by 2. A 3, it's a 3 by 3. It has to have the same sides all the way around. So our square matrix can be a 2 by 2 or a 3 by 3 or a 4 by 4, as long as it's 4 on each side and whatnot. Now, you can I shouldn't say you can only. You can do a determinant by hand. I'm only going to require that you do a 2 by 2 by hand. The rest we're going to put in your calculator, and I'm going to show you. Now, I want you to notice one thing. See these bars right here? They go straight down. This denotes determinant. Our matrix bar goes like this, like a bracket. The straight bars is for a determinant. It tells you want the determinant of this. Okay? Now, when we do a 2 by 2, we go like this. You make an X that goes this way, up like this. You take your product of these two, and you take your product of these two, and then you subtract them. So in this determinant, we would go like this. Take our product of these two, so 2 times 2 is what? 4, minus our product of these two, -3. So what is 4 minus -3? 7. So our determinant is 7. Now, you can put this matrix in your calculator, and then you can do, when you go to calc, when you go to math, instead of doing RREF, you scroll to DET, determinant. So you're going to enter this matrix in your calculator, put it in A, B, C, whatever you like, and then instead of going to RREF, you go to DET, or determinant. We still have to click on the matrix that we made, and we hit enter. And you should get 7. There's a whole routine if it's larger than a 2 by 2. So we really don't have to do that. I just want you to be aware of this is how they do a 2 by 2. A 3 by 3 obviously is going to be a little different because you got more than 2 things sitting in your diagonals. So did everybody find the DET?
No, I got 9.
You got 9?
Yeah.
4 plus 3? Check your matrix. Print out your matrix and make sure it looks like this. Anybody else? Did I get 7?
You said DET?
DET.
The first one?
Yep. You're off. That's a 2, not a 3.
Oh,
Yeah, I said print out your matrix and you can see it.
Yeah.
It just was in wrong. Because that's the problem with the matrix, you don't see it.
Yeah.
So just go to the letter, click it, and print it out. And it's so easy to just like compare it to yours real fast. Okay, so that's how we solve a determinant. Find our determinant. Now, On a 3 by 3, we're just going to put this in your calculator. The routine for a 3 by 3 is very different and is very involved. So anything larger than a 2 by 2, we put in your calculator and we let your calculator do it for us. So you're going to put this in a matrix and then go to Math, Determinant, and find me your determinant for this side. It could come out to be a negative number. It could come out to be a decimal. It's 14, thank you. It only has to be a real number. It just has to be a real number. And a real could be negative, a real could be irrational.
Are we gonna have like a quiz on this only?
No, I wasn't going to do this. Tomorrow we'll do a little review just to wrap this little unit up. It's just like a little sidebar
You should
unit.
give us like a boost and have it. Yeah.
Most of you did pretty good on that test.
Yeah, but like not the other tests. Science.
Yeah, but you did a little extra credit. I counted pies and shirts and everything else.
Oh no, I mean fourth quarter, not third.
Oh, fourth quarter. Oh, I see what you're saying. Fourth quarter. Yeah. Okay. All right. Now, here's a good use for a determinant. And I need you to pay attention. Okay. We have a triangle that exists on a coordinate grid. It has three points to this triangle, right? 3 sides, 3 points, 3 vertices. We take the vertices, we line them up like this. Now, if we did this, we have a 3 by 2. Because that's not a square, we have to fill this column with ones. And then we're going to put it into this formula. Now, the reason it says plus or minus is because your determinant could come out negative. But we can never have a negative area. So therefore, if your determinant is negative, we'll multiply by a negative 1/2 so that we get a positive area. If your determinant is positive, we multiply by the positive 1/2. So we're going to take that formula and we're going to line it up to these. I find the easiest way is to just label these. Just label those like this. Now watch. Here's your area. Your area equals plus or minus 1/2. Let's build your determinant. Just take these pairs and build it like this. 1, 0, 2, 2, 4, 3. Because this is not square, it needs to be a 3 by 3. We're going to put ones down this side. And now all we have to do is find the determinant and plug it in. And then we'll multiply it by plus or minus 1/2, whichever it takes to make our area positive. It's a nice use for a determinant. You'll also use determinants. We use something called Kramer's rule. It's another way to solve your systems of equations, which I didn't go through, but you really don't need it for next year or anything. But Kramer's rule uses a determinant to help you solve the same systems of equations we did. I gave you the easier one, the RREF, because that's by far the easiest. But find your determinant, and we're going to substitute it in, and find our area of this triangle. Because otherwise on a grid, you have to go through your base times height, your 1/2 base times height, right? So if it's not falling exactly where you can count the boxes, you're going to have to do your distance formula to find your base, your distance formula to find your height, and then you're going to have to multiply them and take half. This makes it a lot easier. Find the determinant of those 3 points and just multiply it by 1/2. So what'd you find for your determinant? Okay, we got a 14 and we got a -3. Anybody else? -3. Rachel, check that you have this. Okay, so we're going to plug this in. Now, we have to multiply it by the -1/2 because we need our area to come out positive. If it was a positive number, we would multiply by the positive 1/2. The area of something has to be positive. So it saves us a lot of trouble. If you were to graph this guy, just kind of looking at it, here's your 1, 0, here's your 2, 2, here's your 4, 3. Look at it. It goes this way. I have to find my distance formula here, my distance formula here. I have to go through a lot of trouble in order to find this. So therefore, we use your determinant of your 3 points, and we can find the area of your triangle. Okay? Just a nice little use for your determinant.